How's it going?
Going all right.
I'll start in a minute there.
I hate it when all the due dates just stack up on the same day. It's almost like it does it on purpose.
Seems like it, doesn't it?
Yeah, it sure does. Because if they're not on the same day, they're all of my classes are within 2 days always, no matter what it is.
All right, man. Let's see. I don't think man, there we go. Yeah, I'm not sure. Did I get one? Okay, I shoved that one. Let me see if I got this straight. Today is the 26th, the big blue dot. That's the next set. Then I'm going to try to get it back onto Sunday.
So that was question 2, homework.
Yeah, quiz.
3, the quiz.
Yeah, it's quiz 2 to homework. Which is,
Now, when you said that it was available, I went back to it, and I still couldn't change my answers to it.
really?
Yeah. I mean, I knew what I wanted to change it to because I knew the right answer, but it would not let me go back and edit it. English, you know what I'm trying to say.
Well, one point.
Because it still shows I have a 66 on it, but then I go back to edit it, and there's no way for me to submit another score.
Well, I'll try to poke at it and see what I can find out. I will probably need to do that with several. How about that? Basic. I don't know.
You can just look at that later and
Yeah.
don't worry about it right now. I just wanted to say that before I forgot about it.
Well, let me start up. There used to be a trash can. Oh, it's in the back. No? Yeah, it's in the back.
Oh yeah, swap doors on you.
So we'll do a little bit on curved gates and set up. So on this one, let me make it bigger. So is this an example? No, it's just a figure. Okay. This one's interesting because some books used to call it a pseudo volume. So I'll just try to make that. Well, maybe I'll find one like this in the book to work. But essentially what this is if you imagine that there's this volume of water above it, that's like so, that would equalize if you were able to get rid of the metal and just put that on it. The water would hold everything down, nothing would come up. So essentially, the reason he's got this arrow reversed is because this load is like a pseudo volume. In other words, it's not really there, but here, let's do it this way. We'll get rid of his and say, we have a force going up here and a centroid going up here. Those are the vertical forces there. So you add that and that together, and then you got this force that's right here. And all this water is pushing up. There's also pushing to the left. The upwards push or pull would be from this amount and this amount. The left to right to left would be this amount. So let's go find a problem that's inverted like that and put numbers to it. I hate to dream one up, especially knowing that if he has that drawn, he probably has one. So let me bounce through here, or maybe I'll go to the table of contents, find out exactly where I'm at, and go find problems. And as soon as this comes up, I'll roll down till I find one that looks like that. Okie dokie. Let's try this. Sometimes that works. Isn't that weird? You refresh it and it shows up. So what I'm looking for, of course, is I like good pictures. He has good pictures. Looking for a curved one that's the water is pushing up on. Did I do that?
Yeah, you highlighted that one.
Oh, did I? Come on, there's got to be one that's going upwards. That's a downward. That's the water's pushing down on that. Technically that's that, but I'd like to see a little bit different, but I guess if that's all I got, that may be all I got. Oh, here's a good one. Okay. So the quarter circle pinned at the plate is tied with a cable AB. Unless there's a better one down there, but yeah, that's no better. We might go look at that one, but we'll do this one. If the tank 4 foot wide, determine the horizontal and reactions at A and the tension in the cable. let me get my stuff off there. I'm guessing that that's water. If it's not, I'm gonna make it water. Due to the water pressure, okay. So, let me see if I can do halfway decent job. Okay, and then the arc is this, yeah, okay. So, if I were able to take that amount of water that turned out to be a solid and just stick it on there, it would be the same force. So this is essentially, and I'm going to have trouble finding this, I think, that. Thing is, I'm going to have to find that centroid. Actually, come to think of it, it might not be that hard. But I've got that pushing or pulling, I guess you could say pushing up or pulling up, depending on whichever way you want to say it. And then I got this pushing towards the right against this. That's not a straight. Anyway, it's supposed to be like that. So I'll do that one first. And pressure is equal to gamma H, and that's 6 foot. So at the bottom, P is equal to 62.4 times 6, or 122.34.4, maybe. No, that's way off. No, that's 360 plus 12 plus 2.4.
62.4 times 6?
74.4.
374.4.
Right. Okay, so that's the pressure at the very, very, very bottom. I think he said it was 4 foot wide.
Mm-hmm.
So the thing will be essentially 374.4 times 6 by 4, and then since half of it's gone away because the upper part's gone, it'll be that, which will be, oh geez, about 42. How much?
4492.8.
Okay. And that is up, okay, 1/3 of the 6, or 2 from here, and 3 from there. How can that be 3? That's got to be 4. 2/3 of 6, 2, that's 4, exactly.
So it's 2 foot from the bottom?
2 foot from the bottom, because it's triangular, and this is L over 3 here, and 2L over 3 here, and since L 6, then that becomes 4 from the top, 2 from the bottom. Okay, so now that we got that, that's all great and wonderful and everything. We got to find the upper part, and just to be on the easygoing side, I'm going to go to look at Centroid Locations on Wikipedia, because I know I can go in and I know I can take a square.
Pull a circle out?
Yeah, I know I can do a 6 by 6, subtract out.
Would it be a 6 by 6 or would it be a 6 by 4?
Oh, well so what I'm doing is I'm looking at this, and then I'm going to take that out. So if I took that minus that, would give me that. And then I'd have a centroid here and a centroid here, and I'd use that to find that other centroid. If I gotta do that, I gotta do it. But I bet you that if I go to Wikipedia, let's see. Let's see. List of centroids. He has to have it. No, he doesn't have to have it. He's a very mean person not having that. But I do find the quarter cylinder. Oh man, can't believe I'm gonna have to find that. Why did I pick this problem? It's my own fault. Okay. So how do you do that? You know what? I'm only gonna look for one, say maybe X. So I'll put a coordinate here, X, it'd be the same coordinate here, X, and it'd be the same coordinate here, X. And if you're looking for X bar, you take the area of X bar. The area of this is 6 by 6. The area of that is, what is that? Pi r squared over 3. Wait.
4, wait.
What?
Is it 4R over 3 pi?
Oh, this one?
Yeah, for the quarter circular area.
Yeah. So what I'm doing, okay, so I'll identify this. This is a statics now. Identify this, and I want to get to that. So what I'm doing is I'm listing this being 1, this being 2. I think I have them. Okay, the area of that one, pi r squared wait a minute. Yeah,
4r
pi
over 3 pi.
r squared over 3. Now the x bar here is 3. The x bar there is 4r over 3 pi r over 3 pi. Then a, great, 6 times 6 times 3, 6 times 6, 6 times 6 times 3, 96?
36 times 3.
No, that's not 96.
108.
Okay, so now I've got something interesting. That pi will cancel that pi. That 3, so what is those two? The pi's
6
go
squared times 4
times 6 divided by 9.
6 squared 4 times 6. So 36 times 24 divided by 9 is 96.
Oh, there you go. So now I got this weird thing. Which one gets subtracted? Okay, this one's this one. And if I take this and subtract that one, okay, so I'm
108
subtracting
minus
2.
96.
So I'm subtracting that.
So 108 minus 96.
Yeah, what is that? Like, says a 12? No.
12, yeah.
Okay, 12. Oh my gosh, now what is the sum of that? That's 36, that is some funky number.
Give me a second. $37.69.
Okay, so I've done something wrong here. You know what I did wrong? That number is actually, oh, no, wait. No, I think I did it right. Okay, never mind. that's it. Now, it's really bothering me because, okay, so the X bar is equal to the sum of the X bar A's over the A's. But if I do the sums and I have a minus, wait a minute. I have to subtract, oh shoot. I have to subtract that, but I also have to subtract that. Sorry about that. I'm supposed to subtract that one. That one minus that one.
Oh, okay.
Shoot, sorry about that.
Hang on. Let's go back. 6 times 6, 36. Right, and then 5 times
Oh my gosh, wait a minute, something's wrong here.
5 by 3. What's that? So 36.
You know, I might look for the answer to this in some other location.
Negative 1.6.
Yeah, that doesn't make sense. You know what? That's supposed to be a 4. Why did I write a 3 there?
Oh, I can't answer that one.
Okay.
Hang on. Let's look at that again.
You know what? I think I had a 3 there, and I erased it, and then I wrote a 3 back.
All right. So
It's not possible for that area to be less than that area. That area is.
5 times. Divided by 4. 28, 30, 36. Minus 7.72.
7.72. So now, what is 12 divided by 7.72? Did I do that right? That's the areas, and that's that.
What?
That doesn't make sense. It doesn't make sense. Okay, that doesn't make sense because it has to be, it's going to be somewhere around 5.6, 5.7, 5.8, somewhere in that region. It's going to be somewhere in that region. So, did I do my coordinates correct? 3 over. I'm subtracting off that. Subtracting off that. Yeah, so I've done something oddball there. Okay, here we go. Here we go.
Well, what?
Well, of course, I mean, oh, wait. There was another one down there. Yeah, that's fine. But that's not what I was looking for. Yeah, that's... Oh, that's pretty cool. Look at all that. Yeah.
Square minus quarter circle.
I can't believe it. Pin it. What does that mean? Yeah, I mean that's the way you do it. What did I do wrong? This is called a bad lecture. Let's see if we can fix it. Oh, that's the wrong thing. No, yeah, wait. There we go. So we're back here. We want to find location of that center. What am I doing wrong? 6x6 area. X bar.
6x4.
Well, but what we're doing, we're trying to do this.
Yeah, you're right.
We're trying to take this, and we're trying to subtract off that.
Wait. 6 from, wouldn't it be a 3x3 then?
Well, it's a 6 foot, and then a 6 foot. So it's a 6 foot, 6 foot. Then 4r, which is 4 times 6 over 3 pi. And then, you know what? I'm beginning to think about that one now too. Let's try something. Because now,
Hang on, of course that 96 ain't gonna come out right. We had the 3 there, and
Yeah,
now it's a 4.
yeah.
So, yeah.
let's see. Did you get 144?
I was fixing to say, I'm still in the process, but that sounded better. Where did I screw up? 4 times 6 is 24. Divided by 3 pi is 2.54. Okay. 6 squared times pi.
Ooh. That time I got 72. Wait a
That's
minute.
fixed. I come up with 71.9. That's what I come up with.
Okay.
71.9999, so if you round up, it'd be 72.
Okay, so 36.
That's better. 4.6.
Yeah. 4.6. I'm going to check this one again as well to see. Yeah, that one I got. Yeah. So 4.6, I guess that's probably reasonable. And the other thing is the area we'll need and the location we will need. So this will be weight, will that be gamma times the volume, which will be 62.4 gamma, that is. The volume is 4 deep by the area, which is 7.72. And I get 1927. I'll just say that 1927. Its distance. Okay, how do I do this? The distance from here to here. 4.66. Okay, so at this point, if I somewhat broke away a free body diagram, let's see if I can do it here. Okay, got this. I'll say got hinge force in the X, hinge force in the Y. You got the tension of the cable. You got this force pushing to the right, which we found to be 4492.8. And it was, okay, so we're probably going to sum the moments about the hinge. So it was 2 up from here. And this thing is 1922, but it is a distance 4.66, or 6 minus 4.66 would be 1.34 right there. And that's all you got. So now you'd sum the 4 moments about the hinge, and I'll just make that positive, equals 0. Let's see. I'll take this one first. It goes this way. It would be a minus 4492.8 times 2. We'll take this one next. It's going in a minus way. 1922, 1.34. And I worry about dropping digits. And then I got the tension, and it's 6 foot away. And that's going in the positive direction. 6 times the tension. So the tension of this thing should be, move the negative over to the other side, it becomes positive. 2 times 4492.8 plus 1922 times 1.34 divided by 6, and that should give us our tension. Some of the forces in the Y will tell you there's only that in the Y. That'll tell you that's 1922. That's the force pushing up on it because of the lack of the volume there. The hinge force X will be, it's associated with the tension. That's going to be the tension minus 4492.8. So I don't know what any
T equals 2093.513. Sound about right?
Sure. 2093.5?
513.
Okay, so we'll just take 5.5. That's the tension. Oh, so this flips over. Okay, so let's flip it that direction. Then HX will be 4492.8 minus the tension, or 4492.8 minus 2093.5, around 2399.
23.3.
Okay, so that's the hinge force in the eggs. So outside of that stumble, that it's writing a 3 down here for some reason. I don't know why. And I saw it and I erased it and I rewrote it. I don't know. You know what? I probably just saw that and just copied it over. I don't know why. I guess that is pretty high right there. So yeah, that makes sense. 4.66 is reasonable.
So how do you rationalize that?
Which part?
The 4.66. Like you You were
Well-
guessing like the 5 something?
Yeah, because I knew that, you know, I'm losing some of this, so the X bar had to move. So if you think about it, the X bar has to move somewhere over here. I don't know exactly where, but it's got to move well past this half and somewhere over in this region. I just don't know where. So it had to be greater than 3 and had to be significantly greater than 3. I guess that sort of makes sense. 4.66 probably. And actually, I bet you, if we carried this out, you may find some pi terms. It may end up being 4.4 2/3. It may. I don't know. I just don't know.
Okay.
But I knew it had to be something, you know.
Okay. I was just trying to figure out how you rationalize that, because you can tell you made a mistake, and I was just
Yeah.
trying to make sure I
Yeah.
wasn't missing something.
I bet you if you search long enough, you could find that. But the thing is you already know how to do it. It's just, I was trying to be lazy. Let me see. I'm going to try to be lazy again, although I already did it. Somebody, how about an exhaustive list? Let's see if I can find circular hole. That's no good. Simple composite shapes. That's no good. Oh, oh, here we go. What? This dude's doing it. Maybe? No, he's not. Engineering toolbox. Okay. Yeah, that's fine. Those are that. Oh, it's just all of them listed. Oh, that's no good. Wait a minute. I bet I know how to do this. What's that thing called? Oh, shoot. It's not engineering. SKY. Sieve? That might be it. Maybe. No. Okay, so let's... I thought you could just go for free. Easy model, no lock. Yeah, I'm too lazy to even log in. I don't want to do that. I don't want to do that. Trusted by thousands, millions, and billions of people. Anyway. This is too much. Oh, I know. Let's do this. I misspelled that. Let's see if we can find somebody. Centroid calculator. Let's see. Omni calculator. Hello. I'm the Centroid calculator. What is a centroid? Centroid calculator. There you go. So, I don't know what he's got here. Check out the 2D calculators. Whoa, 2D's calculators. Whoa. Trapezoid. Center of mass calculator. I don't want to do that one. And next to it was the centroid calculator. But I don't see a calculator. Shape. Triangle inside a polygon. That's no fun. Area of a crescent. 18 more. Oh, we're back in the 2D calculators. Yeah. Centroid calculator. Free online calculator. I'm wasting a lot of time, aren't I? Look at this dude. Enter some coordinates. Calculate the centroid of a bunch of coordinates. Okay, that's just triangular calculations. Online centroid calculator. Is that the one I just went to? in calculators. That's basically, it's all triangular. Okay, centroid of a beam section here. You see how he, here. Free centroid calculator. Okay, there's a something. Yeah, that's it. There you go. Here, we're just making a 6 by 6. There you go. Well, you can't do anything else but calculate. There you go. Oh, look at that. Sign up. Show my results. Well, that's not exactly what I wanted, but there's no harm done. Well, you can see by the time I did that, I could have already calculated this. Yeah, I'm done with it. Composite centroid calculator. Oh, the GI. Oh, yeah, those guys are good. There you go. So central one, that's good. Yep. That's not exactly what I wanted. But hey. Let's see. Can I just click that and I go? So you can make this go whoop, like that. There you go.
But it only does the triangular. It won't do the curve.
I don't know. Let's see. How about we do circle? Well, what happened to it there? 1, 2, 3. F is X. That's it. I don't know. I have no idea what I'm doing. Okay. There's the area. X bar 8 adds it up. How about we do this circle? Did it do anything? It didn't change it to a circle, I bet. Nope, didn't change it to a circle.
You just change your title.
Yeah. Oh well. Ooh, look at that. Whoa, lots of things you can move around. Ooh, whoa, 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 whoa. Isn't that nice and animated? Okay, see, that's why you need to know how to do stuff. Because somebody's got to do that. And somebody might not have done that. And look at what he's done to us here. He's been very mean to us here. And so now we have to calculate the centroid of this thing. That's very mean of him. And it's kind of too late to do that one, but here, we'll look at that one. A semicircular gate is used to control the water over a spillway. If the water is at the highest level as shown, determine the horizontal and vertical components of the reactions at pin A and the normal reactions at B. The gate has a weight of 8 milligrams and it's at the mass center at that, I think that's the letter G. It's 4 meters wide. So let's look at this. Here's the funny thing about this. That is, one, the aspect ratio doesn't look like a circle, but if you go look at the thing on the computer screen, it looks just like a circle. Okay, so since all the forces, the little forces all the way up to the big ones, all shove their way through that, they don't produce a moment about B, no matter how deep the water is. So actually, if you look at the drawing as far as finding the reactions at B, you get something weird and interesting. And what you get is a reaction there, and the weight of the gate the water does nothing. It all passes through the center of this thing. Oh, does he say something about the... He just says something about the reaction. So I guess he's implying this T. He never says anything about that torque. Oh, maybe he says something about it at one of the other problems. Okay, so this force is going to be, so if you look at this is 3 meters. So the sum of the moments, make it way positive, equals 0. I'm going to assume that torque isn't there. And then what I'll do is, that is negative 3 meters times F plus 2 meters, 8 milligrams. So, not 8,000 kilograms times 9.81, and that's what the force. Is that right?
Yeah. Is it milligrams or megagrams?
I think that's megagrams. I think the big M is megagrams.
Yeah, that makes more sense though. Because milli means less.
Yeah. So that would be whatever that number is. 2 times 8,000, 9.81 divided by 3. And I do not have a feel for that weight. I just don't know.
150080.
158080. Wait. I may have written
150080.
Oh, okay. 150080.
Yeah.
150,000. Okay. Now the next question is, what was the next question? Oh, determine the horizontal and vertical components of the reaction at the pin. Well, you just had the... Okay. That's really mean. Okay. So what you got is you got that. You got this. So this has a little bitty weight. This has a whole lot of weight. And actually, I got too many things on here. First, here, let me do this one. So I got that one. Shoot, I already erased that, but that's the same thing.
Same dimensions?
Well, in other words, it's a square, 3 by 3 square, and you're trying to find the location of that centroid again. You know what? This is a book that has tables in it. Let me just see something. Let me just see now. Okay, I don't know about this book. I know in the previous book he put them in what's called the front material, or maybe it's in the back material, in papers. Okay, the in papers is stuff like that. Okay, area. Can you give it to me? Come on, man. Oh, wait, no. That's a parabola. He did that. Oh, come on, man. You mean you did that, and you're not willing to do the circle minus the square, or the square minus the circle? Oh, jeez. I'm just too tired today. I lost my energy. So, apparently, where was I? I don't even know where I was now. And then get down here to, keep going to, almost there. Almost, no.
It looks like a water wheel.
There it was.
There it is.
So, in order for me to do this, I gotta come up with that one. And then I've gotta come up with the one that sits above this one. So, it's kind of weird. So, I'll move off to the side over here in order to find the force above here. I gotta find that one and then this one. So those two would be the force on the bottom. This one will be the force on the top. And then I'll have a force going that way. And then I've got to have hinge X and hinge Y. And then technically I'll have my force here, which was 8,000 times 9.81. That's the number of newtons. And then I'll have to have my 550 newtons there. So I'll have to find this one, that one, and this one. But I think I'm too tired and it's already past time. So it's a longer problem. Most of the complexity comes in from the, oh, and by the way, I just find it to here. Because that's where that goes to. Maybe I'll come back and visit this one next time. So I think I started the stream. Yeah, there's a red dot. So I think I'm gonna drop the stream.